Excellent. So, are you ready for some announcements? Good. Okay, Shlomi woke you up. Good. All right, so with EveryOps, you're starting to inherit a lot on your plate. So it's a great career opportunity. You're starting to inherit not just DevOps, or many of you are holding the keys to the organization DevOps platform, and you're basically the oiled machine that runs the software pipelines in your organization. And now you're getting MLOps, and you're getting MLSecOps and SecOps and IoTOps. So you're getting more on your plate, but it's also a big responsibility. So that's something you need to cater for, and for that you need the right tooling. And platformization doesn't happen for no reason, because you may achieve the same goal by integrating different tools, all right? And sometimes you don't have a choice. Okay, but you just inherently, by getting different tools and integrating them, you're fighting against silos. You're bridging against inconsistencies between tools. You're trying to kind of align the entity models of different tools to provide the same visibility that you require. And really, if you want the end-to-end release of automation, if you want the promise of EveryOps, this needs to happen without silos. So they shouldn't exist. Now, we want to share with you now on stage, Shlomi gave some hints of what we're going to show, but we want to really get into the details and dive in. What we've been working on for you, a lot of it based on your input in the past year, what we've done since last Swamp Up, and what we are sharing with you product-wise. And we're going to frame it around removing those silos. Hopefully, we are removing some pain in the process for you, making your life easier, making you more productive. And those silos are first security, then machine learning, and finally the silo between binaries and code. So let's start with security. This is what we call a JFrog, the 7th step. It's a non-conclusive way to look at the software pipeline. Of course, there are many other steps, but it pretty accurately depicts what a modern pipeline looks like by going from the code, running through the CI and the CD, and ending up in production with the process. And below every phase, there are the risks that lure in every phase, and that attackers and malicious actors are trying to manipulate and inject themselves into your software supply chain. And what JFrog has done for you in the past couple of years, we started to eliminate those risks one by one. And I want to show you an up-to-date, accurate picture of what it looks like today. So we'll go from left to right. So on the left, we start with curation. Curation is basically, it's your protection against which open source libraries, and as you will see soon, also models, are allowed to enter your organization. It's a perimeter kind of protection. You can think about it as a firewall. So that's curation. SAST is about scanning your source code, either in the IDE or in your Git servers, for security issues which are by nature 0 days, because they exist in code. Nobody found them before. And then X-ray, this is how JFrog started. Remember, Shlomi spoke about the single source of truth, this asset of binaries. That's how we started our security journey. We just, on Artifactory, we are scanning the binaries. We're doing software composition analysis, which is hierarchical. And then we can find out about CVEs in those artifacts. And on top of that, we added JFrog Advanced Security. This is, guys, a set of advanced scanners that not only can tell you about findings, but they can also indicate whether or not these findings are applicable or not. So we are, by different ways, we're analyzing the config, we are analyzing the execution call to tell you this finding is actually not applicable for you. You can treat it as noise and you can move on with your life. And on top of that, secret detection in binaries. We'll talk about it much more when we dive into security, infrastructure as code, and config scanning. So this is JFrog Advanced Security. And this is also a great point in time to stop and to thank you. Thank you for your vote of trust in us. In the past year, hundreds of you adopted JFrog Security. And it's not just the vote of trust in the product. It's not just that you went ahead and you purchased from JFrog the additional security offering, but it's also a vote of trust in our vision And our vision is that security is part of your supply chain. It needs to be integrated as part of your supply chain. It cannot be siloed. It cannot be point solution. Not just because of the toil and the pain, but also because of reality. You need to have security as part of your automation. So thanks for that. But like always, there are problems. And this is the first one. We call it the deploy chasm. So what happens? You're taking your binaries, and in the continuous delivery process, you're pushing them once they're ready. You take those packages, you take these containers, you push them to runtime, and then the disconnect happens because you're starting to lose the lineage. You're starting to lose you had a very nice software supply chain, but all of a sudden, your runtime binaries are someplace else over the fence, and you don't have the nice visibility that you should have, and we need to fix that. And this chasm is real. It's actually recognized in the industry. This is an IDC quote that says that runtime is actually the biggest blind spot that you have because of this disconnect. And if you look at the reasons for why this exists, why it's a blind spot, so if you look at the existing tools today, it's not just that they are point solution, but they're also very focused on monitoring the runtime. They are completely unrelated to your software supply chain. Sometimes they are very intrusive. Sometimes you need that, but most often you don't. If you have the full connection to your supply chain, most likely you don't need them to be intrusive because you know very, very early about the problems and you can fix them very, very fast. And there are even the ones that are connected, so we have a trend of ASPM tools and other tools that are trying to guess the lineage. They're trying to figure out which binary, which source code and which binary is leading to production. You can go right to left, so it's always outbound from the runtime that you're trying to, that you can discover some sort of a lineage, but you can almost never go left to right. So from the source code, from the binary, figure out what's going in runtime. Think about log4j. You have a new log4j in the market, and now you want to stand on the log4j library and say, is this running in my runtime? Is it active in my runtime now? So this is missing. And this is another realization of this. This is from InfoSec, from a recent article in InfoSec. And what it says is that after 5 years, that sounds like a long time, but it really isn't such a long time for an application lifespan, 7 out of 10 of the applications will have security issues in them. And what's happening here, it doesn't happen over a day, because once you put your application in production, normally it's risk-free. But they found out that after 18 months or so, you start to accumulate technical debt because of disconnect, which ends up in these statistics that after 5 years, 7 out of 10 will have security issues in production. And this is something we want to fix. We want to bridge this chasm. We want to restore your lineage to your software supply chain from production. And the way that we are thinking about it is an integrated dev to production visibility. This is security baked into the pipeline, which needs to be end-to-end and bi-directional, so we need to move laterally between the two edges. It needs to be continuous so that you don't lose this visibility over time, and it has to be non-intrusive. This is our philosophy for embedding security as part of the software supply chain, and then you have no blind spots. So I hope you're excited as me about JFrog Runtime. And really what's happening here is that visibility translates to productivity, translates to remediation. And the reason I'm excited is because we saw ourselves, we saw many of you dealing with the same issues, like you have an issue, you know that you have an issue with an artifact, you know about a new CV coming out, and now this blindness, this blind spot that you have for the runtime, it disappeared. You can do what I call recallable artifacts. You know exactly which artifacts are running out them, you can recall them, you can switch them to a better version. So that's around JFrog Runtime. So let's speak about machine learning now. And again, this is something new on your plate. Again, this is a new career opportunity, but also it's it's a new thing that you inherit. And one of the reasons you inherit that is because your CI starts to embed machine learning flows. So your pipeline, and this is something that you came to us and you actually told us, I'm getting requests from the teams that are from the data scientist teams, from the machine learning engineers, they want to onboard my platform. And this is really happening. And there are several reasons for why it's happening. So the first one is, of course, GenAI. And GenAI accelerates closing two gaps. One of them is a gap of skills, and the other one is a gap of tools. And I'll explain both of them. So if you think about like a traditional inference application, it's normally a very simple application. It can be siloed. It's normally a one-method type of application, so it's really easy to serve it independently. And then you can ask, what is the churn rate that's expected for a customer? Again, like a very simple answer. Is that a cat or a dog in the image that I'm displaying to you? But when we speak about GenAI, two things. First of all, everything is so new. So even if you have the best experienced engineers for machine learning, they are also catching up. And good guys that are not machine learning engineers, they are catching up from the other side. So the merge of skills is starting to happen. But there is another thing. When you think about a machine learning application that is dealing with large language models and with GenAI in general, it's really an application. There's logic. It's not just a one function call. You get input, you put some input, you get some output, you activate tools, you do some divergence in the code based on these tools. You're using Python libraries that are not just machine learning Python libraries. So it's really like developing a new set of applications. And even though everything is so new, like sometimes we are shocked. We're doing something after 3 months. There is something new that the machine learning guys at JFrog come to me and they tell me, we need to look at that, and what we started to work on, maybe it's no longer relevant. Maybe it's arcane because there is something that solves this problem that we're trying to fight, and there's no need anymore. But there are some mature patterns that are starting to form. So if you look at this traditional hype cycle, one of them is what we call RAG-ready organizations. RAG, Retrieval Augmented Generation, for those of you who don't know, it's the way to ground a large language model and make it hallucinate a little bit less by providing more information that kind of relates to your own organization. In most cases, it ends up in an application that you can chat about your internal documentation, ask about things that only your support knowledge base has. So I'm going to take a risk with you and ask by show of hands, who here has a RAG application in development or already in production? Yeah, so quite a lot. So really this prediction, Shlomi showed some other predictions, but this Gartner prediction of 90% of applications in a little bit over 2 years are going to, all the new applications, they're going to have machine learning. It's already happening. It's happening much faster today. So this acceleration also is leading to closing the gaps. And the other thing is around tooling. When you develop a machine learning application, it's part of the same application. We just spoke about it. But even if you look at the tooling, if you look at traditional DevSecOps or DevOps pipeline, there's the dev team on the left side, there's production on the other side, there are the steps that they're going through to put a release in production. And on the other hand, there's the machine learning engineers, the data scientists, and they have a different set of tools. It makes sense because they're still doing something a little bit different. And they have the MLOps platform. And at the end of the day, they are putting a model in production. And some steps, they are largely correlate to each other. They're conceptually very similar in terms of building, in terms of QA, and so on. And of course, there are the horizontal teams, like the ops team and the security teams that are catering for both of them, and they want to control everything when it goes to production in terms of cost, and they also want to make sure that everything is secure. I don't know if you have this situation where your security teams are doing catch-up on being there for securing machine learning. So those two platforms are actually consolidating. Okay, they are consolidating into one unified pipeline. This is bound to happen. And still we are seeing some silos, but it's bound to happen. The other reason that it's happening is not just because your model is part of like a regular application, it's also because your model is universal. And this terminology, this model as a package, we didn't come up with it. It's you that actually told us, you came up with this term, and you told us, I want the same mature DevOps pipelines, and I want the same tooling to serve my models, because for me, a model is a package. And it's not an isolated package. When you think about a model, part of the quality of the model is a bunch of other artifacts that are seemingly unrelated to the model. So it's the data sets that you trained your model on. If you use the base model and you fine-tune it, it's the base model. You change it, you change the quality of the model. It's the Python dependencies, the ones that are part of your machine learning, like natural. But it's also the Python dependencies that are part of your application that is serving and interacting with the model. It's the runtime containers, it's the parameters, and it's not a conclusive list. There are other things that are inherently part of the quality and the security of your model. And when you deploy machine learning application, you need to factor this in. So all this consolidation is exactly what led us to buying Qwak. Shlomi spoke about it just before. And today I'm happy to announce JFrog ML. And what is JFrog ML? JFrog ML is not a new name for Qwak in JFrog. It's not a rebranding of the Qwak. We actually like the DAX very much. And Qwak is an end-to-end solution to take a model, bring it to production very, very, very easily, even in a matter of minutes. It's that simple. But what we're bringing to the table is a new platform-level experience for machine learning. And this platform-level experience is about consolidating two levels of trust. Shlomi also spoke about trust in the beginning. That's part of the core values that you need to have in your software supply chain. So the first trust is a trust of machine learning workflows. So all the steps that you need to have in your machine learning or MLOps platform in order to deliver a model all the way to production. And the second one is the trust that you are more familiar with, the trust around your assets, the trust around your artifacts, not just about the management and the curation, but also around scanning them. And the way, I'll let you finish taking the pictures, but I have another slide that kind of depicts it more, I think it's more natural. So I'm switching to this one. So if we want to look at it, what it looks like in the JFrog platform, so the yellow parts, the JFrog ML now, is everything you need to get a model to production. So it's a full end-to-end solution with training and fine-tuning and experiment tracking and feature store and vector store for your data and model serving. So you can actually serve the model, and model monitoring. Once it's served, you get the feedback loop so that you can keep improving. And in Artifactory and in JFrog, we have, so in Artifactory, we have the Hugging Face proxy, caching proxy, that also works with curation. We have the model registry for your own models, and we have, of course, the Python dependencies, the containers, so the whole universality that keeps all the assets of a machine learning application. And then on top, I mentioned already curation, but also scanning for the different types of artifacts, including runtime now. So wherever we're building something, we're making sure it's coherent and it's well integrated across the platform. So what we're bringing you now is an unsiloed machine learning, because it's a single platform for both your workflows and your machine learning assets. It's universal, it's secure, and it's curated. And there is no offering like that it's equivalent in the market that really combines both of best worlds, like the secure, trusted DevOps practices with a very easy to use machine learning end-to-end solution for taking your models to production. I think I ought to say thank you for the teams. You have to understand this is a two-month thing in integration. So we have a lot planned for this integration, but I think you were able to see the first buds, so to speak, of integrating DevSecOps and MLOps under a single platform. Curation, by the way, the policy for curating models is something that you requested. What we learned is that the thing with models is since they are still kind of untrusted, you want to manage a list of models that you allow in the organization, not just models, but actually model versions to that level. So this is how you want to curate and control models. Maybe with time it will become even more sophisticated. But this is GA now, and you can go ahead and start using it. OK, so moving on to the deck. If you can switch back. Thank you. So even if you have the best platform, even if you can take your model in a trusted way, put it in production in a matter of minutes like we just saw, you're still going to face two issues. Those issues are quality and speed. What I mean by that is that, oh, I'm sorry. Thank you. OK, so pretend you didn't see that. So the issues are of quality or of speed. What I mean is that quality, you want to get your models from a trusted source. We just saw the curation that can handle some of it. You want to serve your models at scale. They tend to be quite large in the gigabytes range. So you want to be able to scale them and download them very, very fast. Of course, you want to have them free from security. And they need to be optimized for speed. Which is it's a big issue. Everyone that was trying to run machine learning knows how complicated it is to not fine-tune, but tune. It's an overloaded term for machine learning. Tune your model to the exact hardware to extract every bit of the GPU when you run your model. So that's a big issue. So you want to run fast. You want to run with trust. And this is exactly why we are speaking now about our integration and collaboration with NVIDIA, specifically around NVIDIA NIM. So it's not a surprise anymore. Shlomi spoke about it in the beginning. But I want to dive in and show you what it's all about and give you some more of the technical details, even show you a demo of the first version of that. What is NVIDIA NIM? It's exactly solving the problem of having a trusted source for your models, but also making sure that your models are super optimized for the NVIDIA hardware. So basically, you have a container on top. So you see on the top that you do a Docker run to fire up the container. Normally, of course, you wouldn't do that. This is what we're going to show in the demo. But normally, this is going to be a Kubernetes cluster that is serving your machine learning models. So you have a container. It's optimized for speed. It knows in runtime how to pull the model that is most fit for your NVIDIA type of machine. NVIDIA catalogs and distributes both the containers and the models. And like I said, they are resolved in runtime, which is it's a thing for machine learning. You normally don't package the model when it gets very big. Normally, that's something that you resolve in runtime. So we have many joint customers that were super excited by this feature by NVIDIA, but they told us, and they actually told NVIDIA too, we want that as part of our single source of truth. We want to have that in Artifactory. We want to run it locally. That's like, if we need to use it, this is how we want to use it. And that's exactly what we did with this integration. So Artifactory proxy the NIM containers from NVIDIA. It also proxies the NIM models themselves from the NVIDIA cloud. Curation and scanning happens on all the artifacts, on the models, on the containers, on the Python dependencies, and so on. You get the local network speed, because everything is cached locally, so you don't have to download it over the internet. And you get the flexible deployment, because you can run it on-prem, you can run it in the cloud, you can run it hybrid, and you can also run it in a fully air-gapped environment. So this is also sometimes common for models. And we're also working on integrating and looking how to integrate firing up this model from JFrog ML, from Quack. So this is what you see here on the diagram. And I want to give you a quick demo for what it looks like. So I hope you can see from far. So basically, we are here in the administration page of Artifactory. We see two new repositories. One is a Docker repository, so this is not new. The only thing that is new is that now it's pointing to the NVIDIA container registry for NIMs. So we'll go ahead and close that. And then there's a new type of repository in Artifactory. It's a NIM repository. So you can see that that's a new type that we introduced. And it's pointing to the NGC. For those of you who can see, it's pointing to the NGC URL to download the models. And now we're going to pick a model run, so we'll close that. So we're going to the Llama 3 page. This is on Nvidia website. There are some instructions here on how to do the Docker login and get your credentials. Normally, you don't need to do it, but we're just going to show you how to run the model. So we're going to copy the instructions for running the model, going to the console, paste it, and the only thing we have to do is we have to change the URL to Artifactory. So this is a cloud instance of Artifactory. So this is pointing to the Docker registry in Artifactory. It's downloading the containers, and it's really what we did is we ran a Docker run command. It's downloading the containers, and once the container will spin up, so it's very, very fast and it's over, it also downloaded the model. You have even a simple output that shows you how to interact with the model. Let's go to the application now. So we're going to Artifactory. So what we will see here is that we cached in the NIM model. So there is a new NIM model for the Llama 3 cached in Artifactory. You can see the version. And there's, of course, also the container that was actually cached before the model. So if we go to the container, we can see the version that was cached. We can see the regular things like the different layers of the container. You can see the security view, the fact that we don't have any malicious packages in it, and even a breakdown of the SBOM of the container according to different packages like Debian and NPM and so on. OK, let's finish up. Let's interact with the model. So we're sending a curl request to the model. We're actually asking for a song, a 4-line song about a frog. So this is contacting Llama 3 on Nvidia. And there's a small song about a small frog that lives on the pond, on a lily. So this is, guys, this is just a taste of it. It's still a work in progress. You're welcome to come to the Nvidia booth or to the JFrog booth to learn more about it and get some more details about the internals of how this is all working. So that really concludes the machine learning section here. And we're moving on. So last bit, code and binaries, the silo between code and binaries. This image probably looks familiar by now. So this is the 7th step again. And remember, I spoke about the deploy silo. There is another silo here, which is the CI silo. So if you think about CI, it's really the machine that takes your code and puts it in the binary store. So it's, even Thomas spoke about it. It takes your code, compiles, packages it, converts it to binaries. And the silo here is because of this transformation, again, you're losing the lineage. Okay, so code and binaries, it's natural that they are being managed in 2 separate systems. It's 2 different systems for managing code and binaries. But really, it's not a natural thing to have. You shouldn't be losing your the relation between your code and binaries, because at the end of the day, it's the same release, it's the same team, it's the same application. And in order to bridge this chasm, we want to maintain this line. So it needs to be bidirectional, so you can move across. You need to have one security view. So for your binary scans, for your code scanning, you want to consume them in a single place. In terms of projects, it's like I said, it's the same team, it's the same application. You want to be able to manage even though you're dealing with 2 different systems, you want to manage the relation between the teams and the projects in the same way. So you want to have that mapping. And then you get the full lineage. And then what you can do is really magic. You can ask things like, who built the release? Who wrote the code that built the release? And now, in runtime, who wrote the code that is running in runtime? Do I know that this code is actually running in runtime? And this is exactly what we did with the GitHub integration. That's exactly the reason bridging the CI chasm is exactly why we integrated. The way that it happened, so we kind of spoke about it a bit, it started in the field. We have many joint customers, and JFrog solution engineers and GitHub solution engineers were actually completing this integration by hand. They were doing this manually to fix this chasm because customer asked them to, because naturally it's the same pipeline. So we announced that in Q2, and this is what we announced. We announced an integration which is not an integration of features, but it's a really best of breed of two platforms. GitHub, in terms of code and CI, connected all the way to the binaries, to Artifactory. That's the middle section. And then you have, we will speak about it today, Copilot using JFrog Curation and JFrog Catalog. But I don't want to steal the thunder for the next, so I'll wait a little bit with that. But this is really very cool stuff. And on top of that, you have security. So you have GitHub Advanced Security and JFrog Advanced Security together providing a full coverage, an umbrella of security for both code and binaries. So this is in high level what this integration looks like. And what happened when we announced in Q2 is you were waiting for it, you started to adopt it, and also give us back some very valuable feedback. And today we're going to show the result of this feedback, what we've been working on as the next integration of GitHub and JFrog. So just to give you a glimpse, because there is a dedicated session and you will be able to see all the details, but just to give you a glimpse of what we've done, the first one is around project mapping. So now you no longer have to map between a JFrog repository and a GitHub project manually. We give you a very flexible rule-based mapping. So this is fully dynamic and you can templatize your mapping between the projects. That's one thing that we've done. Again, it's around OIDC. So that's the mapping between the projects. The other thing that we've done is we highly improved the end-to-end release lineage. There's a new navigation that not only looks better, but it actually provides much more information that allows you to go from your GitHub actions all the way to Artifactory and back. And what we are doing now, which is opinionated and different, we are pushing an SBOM for every GitHub actions that you're building and you're depositing artifacts in Artifactory. By default now, we are pushing an SBOM. This is what we call build-in for those of you who are familiar with this standard. We are pushing that to Artifactory. You can opt out, but now it's by default on. And what this gives you, it completes the journey. It completes the lineage because now when you have build-in for an Artifactory, you can navigate to the source. Okay, so it gives you this metadata that was missing and you had to opt in before. Now it's, you don't have to do anything. It happens automatically out of the box for you. Then we have a single security pane, basically giving you, as a developer, the feedback early on where you are hanging out inside the GitHub security panel view. We spoke about the need to also scan, of course, source, but also binaries, and why, if you're not scanning your binaries, it can amount to negligence. Basically, there are some vulnerabilities, there are some security holes that can leap in the CI process between, exactly like happened in the keys to the Python kingdom. You can leap security vulnerabilities without even knowing them to your binaries, and you're only going to be able to find it once you're scanning your binaries. And the big thing is that we're giving you one place to see the binary findings, the source findings all together. It's very easy to differentiate and see which is which. So that's also coming up. And finally, the integration that Thomas and Shlomi spoke so much about, the integration with Copilot. So guys, you have to wait for the demo. Believe me, you want to wait for this demo. It's really an advisor for anything package. It knows Artifactory, so it can navigate to Artifactory. It's familiar with your own organization, so it knows about your curation policies. It knows about what packages you're storing. You can even ask questions about your sector. So if you want to know the popularity, which only JFrog can provide because we can use the anonymized consumption data based on seeing how many logos in the finance sector is using that version of a certain artifact. So think about the quality that you can gain from this integration, and these are only just the first steps of it. So we are very, very excited about it. This is in beta, so we are working with GitHub according to their timeline, and we are part of a selected group of partners, but the only ones that are providing this functionality in Copilot for binaries for packages. So that is coming up. Again, Brian and Jonathan are going to come on stage in the next session and show you. You'll have to stay tuned and equipped with some patience. Okay, so single source of truth. We couldn't have done all that unless you trusted in us to deposit your most precious assets with us, which is your software releases. This allows us to serve you and to build more and extend the functionality by having the control point over anything that gets into your release and goes out as your releases. So just to recap on what we announced today, and so JFrog Runtime Security, end-to-end bidirectional navigation, all the way to the runtime and remediation in the runtime. This is GA. JFrog ML, what Yoav just showed now, again, DevSecOps and MLOps unified to a single platform, again, GA available today. The JFrog and GitHub integration, again, you'll see it in the next session, GA available now. The Copilot extension, as I mentioned, super exciting. Wait for it. It's in beta, but to be released very, very soon. And the collaboration between JFrog and Nvidia around NIM. This is a work in progress, in development. Come to the booth, get more details about it, to learn more about this.